Morning, Algebra 2 students. Today, this is Miss Bendon. Hi. Today our aim is how can we build the graphs of sine and cosine using the unit circle. So to start out, what I've given you is 4 periodic graphs and 4 non-periodic graphs. So take a look at those and see if you can make a guess what you think it means to be periodic. Okay, so when we look at periodic graphs, we are looking at graphs that have a repeating set of y values or a repeating pattern. So, and by repeating pattern, I don't just mean that it repeats once or twice, I mean that it repeats over and over forever. So if we look at some of these periodic graphs, I can sort of trace this graph with my finger, not very neatly because touchscreen, but that pattern of that little loop is repeating on this graph here and here and here, and is just going to repeat forever to create the shape of the graph, and that's what makes it a periodic graph. And if we look at another one, we've got this pattern that looks like that repeats over and over and over to create the graph. And that's not the case for these non-periodic graphs. So the reason we're defining that is that sine and cosine, when we graph them, so if we're graphing the equation y equals sine x or y equals cosine x, we do get a periodic function. We do get a periodic graph. So let's look at how that periodic graph is created. Sorry, can you hear my cats yowling at each other in the background? On the unit circle, we discovered that the x-coordinate of where an angle hits that unit circle is that angle's cosine value. And we found that the y-coordinate of where an angle hits the unit circle is the sine value. So if we have an angle that takes place at 0 degrees, or if we wanted to write it as radians, it would still be 0. I need a thinner line because I'm not going to fit in this chart. Okay. So that angle is right here, and it hits the unit circle at the coordinate 1, 0, which if cosine is our x-coordinate, that means that cosine of 0 degrees is just 1. So then if we start to look at the angle 90 degrees, which is right here, 90 degrees, remember, what is that in radians? Pi over 2. So pi over 2 radians, or 90 degrees, is going to hit the unit circle at the coordinate 0, 1, which means that the cosine of 90 degrees, or the cosine of pi over 2, is 0. Cosine of 180, which is going to be right here, is going to be, and now remember that's pi radians, and so the cosine of pi radians is going to be -1. And one more colors. Let's pick purple. I like purple. 270 degrees, or 3 pi over 2 radians, is going to give us a cosine of 0 again. And then 360 coming, we need another color. How do I feel about like a nice orange? Coming all the way around a full circle, we get back to here, and that is 2 pi radians, and goes back to having a cosine of 1 degree, or of a cosine of 1. So let's go ahead and graph that equation, y equals sine x. And if we're graphing the equation y equals sine x, think about where the x is in that. X is what we're taking the sine of. So our x value of this graph is the angle, And our y value, whoops, I want to do cosine, not sine. Our y value is going to be the cosine of angle x. So when x is 0 radians, what did we say our cosine was? We said that it was 1. So let's think about what scale we want to do. Can we put 1 here? We'll make that 1. So that's our point. And then we come over to pi over 2 radians as our angle and our cosine. So our y value is 0. So we're going to be right there. We come over to pi, which is a cosine of -1. We come to 3 pi over 2 and are back at a cosine of 0. And we come over to 2 pi and we are back at a cosine of 1. And if we connect those points, we get the repeating pattern of a sine graph. And again, it's periodic. It would go on forever. Let's look at how that curve is being formed entirely. Where'd that go? Is that it? Yeah. So if we look at a cosine graph, remember that the x-axis is the angle and the y-axis is the cosine. As we move around this unit circle, we're going to see what the x-coordinate is, or the cosine is, at each of these angles. So as we come around, these angles are going up. Our x-coordinate is shifting around that circle to create that, what we call a cosine wave. So look at it again. Right now, that x is as far out as it gets over here, but then it gets smaller and smaller, and then bigger, and then smaller, and then bigger again. And so that's how we form our cosine graph. And the sine graph is going to be formed similarly, but now instead of looking at the x-coordinate around the unit circle, what are we going to be looking at? We're going to be looking at the y-coordinate. Sine is the y-coordinate. So again, on this graph, our x-coordinate is the angle, and our y-coordinate of y equals sine x is going to be the y value of that angle's point around the unit circle. And we get a very, very similar periodic curve to what we had when we looked at cosine. All right. So how are sine and cosine graphs similar? How are they different? The big thing that I'm going to have you focus on right now is that let's look at the y-axis for where we see the major difference. If we look at the y-axis, they're crossing in different points, right? The sine is crossing, graph of sine x is crossing the y-axis at 0, and the graph of cosine is crossing at 1. Let's add some vocabulary, though, to talk about this. So these are really the 4 features of our periodic functions that you're going to need to know, the 4 features of the graph. So midline, I'm just going to switch to typing for these definitions because my handwriting on a touchscreen is bad. So midline is the middle line of the graph. That's what it sounds like, right? So when we say the midline, we mean the line horizontally that we can draw through this graph that divides it exactly in half. So like this graph has a maximum of 1 and a minimum of -1. What's the value that's exactly halfway between 1 and -1? It's going to be 0. So if we draw a line along y equals 0 here, we divide our graph exactly in half, and that's called the midline. And the midline is the same for this graph of sine because we've still got this maximum of 1 and this minimum of -1. And so we still have a midline at 0. And in general, if you're looking to calculate the midline, a great way to do that is just to do the min plus the max divided by 2. Because that's really, you're taking the average between the minimum and the maximum that way, which will get you the midline. And then amplitude is really related to midline because the amplitude is the distance from the midline to the maximum or to the minimum of your graph. And the distance from the midline to the max will always be the same as the distance from the midline to the minimum because that's basically the definition of midline, right? It's the place that's halfway between your minimum and your maximum. So for these graphs, if we want to measure the amplitude of sine x and cosine x, we're going from this midline that we found at 0 up to the maximum, which is at 1. So the distance from 0 to 1 is 1. Or we can measure down to the minimum, and the distance from 0 to -1 is also 1. Keep in mind that this is a measure of distance, so that means that it's a positive measure. Even though we're going from 0 to -1, the distance there is 1, and we would say that the amplitude equals 1. And it's the same over on this sine graph. We go from this midline up to the maximum, and it's a distance of 1. So we have an amplitude of 1. And then period, you remember when we defined periodic functions, we said they had this pattern that was repeating over and over again. And I could grab that a piece of that pattern and move it and cover the whole graph. That piece that I'm moving is called the period. It's the piece of the graph. What was that? Sorry, I think my cat broke something. It scared me for a second. Okay, what was I saying? Okay, this piece of the graph that can move, that is one period of a periodic function. So more specifically, when we talk about the period, we're talking about the length of one repeating piece of the graph, or one repetition of whatever that pattern is. And by length, I mean the length of its distance along the x-axis. So if I look at one repeating pattern of this cosine graph, I'm going to go ahead and always start finding period if I can by starting at the y-axis because it'll make it a little bit easier to find. So to find the repeating piece of this pattern, I'm starting at the maximum. I'm going to trace this graph until I get back to the maximum. And I get back to the maximum there. And that is one repeating piece of my pattern, because if I picked up, whoops, no, I want to move this, there we go. If I picked this piece up and moved it over, it would fall exactly on the graph again. That would be what my cosine function looks like continuing forward. And then I'm looking at the distance along the x-axis of that entire pattern to happen once. So I'm looking from where it started to where it stopped, and it took me 2 pi for that pattern to happen once. So the period of this graph is 2 pi. Let's do the same thing with sine. We start at the midline. Now we're at the midline going up. We come around and we hit the midline again. Is that the whole pattern? If I pick that piece up, whoops, I pick that piece up and move it over on the graph, it doesn't fall back on it. That's not the whole pattern yet because it's not where the graph starts to repeat itself. In order to get the whole pattern, what I need is, whoops, I need to trace the graph from where it starts at the midline, up to the maximum, down to the midline, down to the minimum, and back to the midline. And that is where my graph starts to repeat itself again. And I could sort of move it over and see that that would be the cosine or the sine wave over and over again. So that's period, and then frequency is the number of times that the pattern repeats between 0 and 2 pi. And why is 2 pi an important value on our x-axis? Why would I be paying attention to 2 pi specifically? Well, remember that 2 pi radians is 360 degrees. So we're really saying that frequency is the number of times that this pattern repeats over a single circle. And since our period is 2 pi, it took us the entire value from 0 to 2 pi to get 1 period. The frequency in the case of these graphs is 1. And a good equation for finding period or frequency is that period is going to equal 2 pi divided by frequency, and frequency is going to equal 2 pi divided by period. Did I say that right? Period equals 2 pi over frequency, frequency equals 2 pi over period. Okay, this video is getting kind of long because this is a lot of information all at once with all of that vocab. So let's do one example together, and then I'm going to, and then I'm going to let you loose, but we didn't talk about this piece. So let's also talk about this piece. Is this a sine or cosine graph? So remember, we said that we need to look carefully at where we cross the y-axis when we're deciding whether we're looking at a sine or cosine graph. So if we go back to this, we said that the cosine graph crossed at that maximum of 1, and the sine graph crossed at 0 here. We now have a vocabulary word for where the sine graph is crossing the y-axis. What important point is this? We're crossing at the midline. So cosine graphs will cross the y-axis at the maximum or the minimum of the pattern. Sine graphs will cross the y-axis at the midline. So looking at example 1, let's start by saying, is this a sine or cosine graph? And we can look at where we're crossing the y-axis. We're crossing it at 4 here. If we look at this pattern, are we crossing at the maximum, the minimum, or the midline? Well, we're crossing at the midline, so that means that we have a sine graph. So let's find the midline. Just based on the fact that that's where we're crossing, we can already say that the midline is at y equals 4. But let's just double check that. Remember, our equation that we said we could use is do the maximum plus the minimum and divide by 2. So the maximum is at 7. Plus the minimum is at 1 divided by 2. 7 plus 1 is 8 divided by 2 is 4. That checks out. We've got a midline at y equals 4. Notice that I wrote y equals 4. I didn't just write the number 4. The midline is a line, which means it is an equation, so it should always be y equals a number. The amplitude then is the distance from the midline up to the maximum. So let's just see, we're going from 4 to 7. The distance from 4 to 7 is 3, so we've got an amplitude of 3, and then our period is how long it takes on the x-axis for this pattern to repeat. So if we start here, we're starting at the midline going up, hit the maximum, come back around down to the minimum, and hit the midline again. There's our pattern. It took us from 0 to pi, so we have a period of pi, and then frequency, we said, was going to equal to the period to 2 pi divided by the period, and the period is pi. So what's 2 pi divided by pi? The pi's cancel, and we see that we have a frequency of 2. And remember, our definition of frequency was how many times the pattern repeats from 0 to 2 pi. So it happened once, it happened a second time, it took us 2 repetitions to get from 0 to 2 pi. All right, guys, this video is already 20 minutes long. I'm sorry, we're gonna stop there and save the rest of this lesson for another video. You have some delta math practice, so go ahead and try that, and feel free to reach out with any questions. Bye.